What's up guys, and welcome to this video on the 2017 supplementary exam. We're going to go through all the questions and basically show you how to answer them. Okay, cool stuff. So let's start with the multiple choice. So it says question 1.1, which group of quantities contains vectors only? Okay, quite a standard question for the first one. Okay, so let's go through all of it. Let's see. Okay, so acceleration is a vector, momentum is a vector, speed is a scalar. Okay, so that is not an option. B, velocity is a vector, weight is a vector, electric field is a vector, and therefore our answer would be B. So question 1.1 we can say is B. Let's just go through the others. Okay, energy is a scalar, so that is not an option. Work is a scalar, so that is not an option. Okay, cool stuff. The velocity versus time graph for a moving object is sketched below. Upwards, so upwards is taken as positive. Okay, so let's understand what's happening here. So we're starting this graph. This is a positive displacement in black, and this would be a negative displacement. Okay, obviously here the velocity is 0. Okay, so the option says, okay, so for option A, the object is traveling downwards throughout its motion. This is not true because of this area right here. So A is not an option. The object is traveling with a constant velocity throughout its motion. This is also not true because it starts at positive v and ends at negative v, so those are not the same. So a constant velocity would look something like this. Let's say velocity time, and this would be a constant velocity. Okay, the object is decreasing. The object speed is decreasing throughout its motion. Okay, that is true for this first section because now we're going from a positive to 0, but from 0 onwards, it is increasing its velocity. So that can't be true either. And then the next questions, or the next option is the object is traveling with a constant acceleration through its motion. Okay, so using a velocity time graph, we can use the gradient to give us the acceleration, and the gradient throughout its entire motion is constant, so the answer is D. So question 1.2, we can say the answer is D. Okay, cool stuff. Okay, so an orange ball is traveling along a smooth surface with an initial velocity u when it is struck by another ball v. Okay, after the collision, it's struck by another ball. After the collision, the orange ball is traveling with a speed of v, which is a greater magnitude than u. In what direction, or u, which is shown below? Okay, so the question says, which vector best indicates the direction of acceleration of the orange ball during its collision? Okay, so basically what we need to do is create a head-to-tail vector kind of. So if we had u going this way, and let's say option A would be in black, I'm going to do option A. Option A would be that. So our final V would be that, which is not what we have. So that's not an option. Okay, so for B, we have V would be, the collision would be upwards, straight upwards, and V would be like that, which is also not what we're looking for. With option C, we have the collision like that, and our final vector V like that, which is what we're looking for. So the answer is C. So question 1.3 is C. Okay, so Peter pushes two books on a frictionless surface with a force F as shown in the diagram. The force that book 1 exerts on book 2 is X. The force that book 2 exerts on book 1 is Y. The magnitude of the force X compared to force Y is, okay, so basically what we're looking at is the forces acting in between here. Okay, so the force, that would be X, and that would be Y. Okay, using Newton's third law, we know that the forces are equal. Okay, so this is basically a theory question. So question 1.4, the answer is A because of Newton's third law. that states that when object A exerts force on object B, then object B will simultaneously exert an equal force of opposite direction. Okay, then we have, so question 1.5, the momentum of a car versus time is illustrated in the graph below. Okay, so momentum, we denote the symbol P and is equal to m times v. The gradient, so we're looking for the gradient. Okay, so gradient is equal to a change in y over change in x, which is going to be our momentum over our time. Okay, so now I'm going to focus on the units of momentum. Okay, so the units, so this is equal to m times v over t. Okay, mass has got units of kilograms, velocity is meters per second, and time is a second, so it's a second squared, right? And if we look at this, this is the units for newtons, or a force, because a force equals mass times acceleration, which is kilograms meters per second squared. Okay, these units are same, so the gradient is equal to the resultant force B. So question 1.5, the answer is B. Okay, so question 1.6. Okay, all the questions before this were relatively easy, straightforward kind of questions. This one will take a bit more work to get the answer to. Okay, so a ball is thrown vertically upwards with an initial velocity vi. So a ball thrown upwards with an initial velocity vi reaches a maximum height y. The velocity of the ball when it is halfway up is question mark. Okay, so we know that we're dealing with a constant acceleration problem, so we need to start with the UVAT. Okay, so I'm going to do the UVAT for, so this ball is, the motion of the ball is basically something like that, right? Here it's the datum point or the starting point or the reference point, and this is the top where the velocity is 0. So I'm going to start with that. So I'm looking between points 1, the datum, and the top 2. So for 1 to 2, the UVAT, UVATS, okay, so our initial velocity we know is VI, our final velocity at the top is 0, the acceleration is minus g, so I'm going to take upwards as positive. Okay, the time is unknown, and the distance s is equal to y. Okay, then I'm going to use the equation v squared equals u squared plus 2as. Okay, so v squared is 0 squared is equal to vi squared plus 2 minus g times s. Okay, so now I'm going to solve for s. So if we take that across, everything becomes vi squared over 2g is equal to s. Okay, so I now know what the total distance is in terms of vi squared, v and g, basically. Okay, now I'm going to work from 1 to the halfway point, which is, let's say 3. Okay, so between 1 and 3, the UVATs are going to be the following. Okay, so u is still vi, v is unknown, acceleration is minus g, taking upwards as positive once again. The time is unknown, and s we calculated, it's halfway up, so it's going to be vi squared over 4g. Okay, so that's just half of this value right here. And then I'm going to use the equation, the same equation, v squared equals u squared plus 2as. Okay, so what we have is v squared v squared is going to be equal to vi squared plus 2 times g, which is going to be minus g, times s. Okay, what our s we know is vi squared over 4g. Okay, these g's cancel, this 2 cancels with that, so it becomes a 2. Okay, so what we have is v squared equals vi squared minus vi squared over 2. So I can pull out a vi, So vi squared 1 minus a half v squared. Okay, square rooting. Okay, so this is also, so it's basically vi squared over 2. 1 minus a half is a half. Okay, and then I'm going to I'm going to square root both sides, is equal to vi over square root of 2. Okay, so we're looking for that option, and that would be option 6. So question 6 is option C. So question 1.6, the answer is C. So like I said, this can be done in a number of ways. You could have solved for time or a different variable, but this is the way I went about it, and we get the right answer. Okay, so the next question says, an object has a weight of 88.2 newtons on Earth. The gravitational field strength on the moon is 1.64 meters per second squared. What are the weight and mass of the object on the moon? Okay, so the mass on the moon and the Earth are both the same. So let's start off with that. So we know that the weight, it was mg. We know the weight is 88.2 is equal to the mass is the unknown times g of 9.8, and what we get is, if we do this calculation, we get a mass is equal to 9 kilograms. Okay, so we're left with option B and option C. Then we want to work out the weight on the moon. So weight on the moon is equal to mass times the gravity on the moon, which is equal to 9 times 1.64, and that is equal to 14.76 newtons. Okay, and basically we're left with B. So question 1.7, the answer is B. Okay, cool stuff. Question 1.8. Okay, so a metal sphere K has a charge of 4 nanocoulombs, and an identical sphere L has a charge of -8 nanocoulombs. When the spheres are placed 5 millimeters apart, sphere K exerts a force F. The spheres are then touched together and then released in their original position. What is the magnitude of the force that sphere K now experiences on the sphere L? So basically this we need to do in two parts. We need to figure out what the force F is, and then we need to figure out what the new force is once they've been touched and moved to the same position again. So let's start off with calculating F. Okay, so F, we can use the equation equals K Q1 Q2 over R squared. Okay, remember they moved back to the 5 millimeter space, so both times, in both situations, R is the same, and so R squared is the same, and K is also a constant, so we don't really have to care about those, so I'm going to take those to out. So it's going to be K over R squared, and then Q1, Q2, I only care about the magnitude, which is 4 and 8, so we're left with K R squared times 32. Okay, so that is the value of F. So the F new is going to be K Q, let's say 3 and Q4 over R squared. Okay, so we have to work out what K 3 and 4 is. Remember, when we bring them together, when we bring the spheres together and we touch them, they're going to try and balance each other out. Okay, so what we do is K3 is equal to Q3 is equal to Q4 is equal to the average, so -8 plus 4 divided by 2, which is equal to I think it's -2 if I'm not mistaken. Yeah, so it's equal to -2. Okay, so Q3 equals Q4 equals, okay, so -2. So I'm going to take K over R squared, because that's the same, times, again, I only care about the magnitude, okay, and that equals K over R squared times 4. So now I need the new one in terms of the old one. So basically, if we look at these two, okay, This is the same for both of them, and so F nu is going to equal F, okay, but divided by 8. So if I divide F by 8, I get F nu. Okay, so we're looking for F nu is basically 1 over 8 F, and that would be option A. So question 1.8 is equal to A. Okay, so an electric generator is started at time 0. The total electric energy generated during the first 5 seconds is shown in the graph, during which time interval is the maximum electric power generated. Okay, so what is our equation for power? Power is equal to work or energy over time, or work over time, which is equal to energy over time. So that is represented by our gradient. So basically we're looking for where the gradient is a maximum, okay? And obviously that is right there between 2 and 3 seconds. So question 1.9 is equal to C. Okay, and then the last question, a conductor carries a current perpendicular into the page between the poles of 2 magnets as shown. In what direction will the conductor experience a force? So basically what we're going to have to use is our left-hand motor rule. So how does that work? Okay, so our left hand, let's draw something like that. Okay, and we've got our middle finger pointing into the page because it's F is our force, B is our flux, and I is our middle finger, which is pointing into the page. So let's say it's downwards basically, which is our current. And we know that the current, so basically we put our middle finger, our left middle finger into the page, the flux flux. So the flux B goes from north to south, okay, and what we're left with is our thumb indicating the direction of the force, which is that way, which is C. So the answer is, for question 1.10, the answer is C, using our left hand motor rule. Okay, cool stuff, guys. So in the next video I will do question 2. But yeah, so that was the MCQ. Again, I usually say that you should do the multiple choice last because they try to trick you sometimes. But as you can see, it's not too difficult. Okay, so thanks for watching, guys, and I hope you found it useful.